Hello everyone! In my last video, I talked all about motor gearing from why to how. Today, I'll be talking about motor power, specifically how to pick the right one for your motor to run on. You have to match the correct power source for your motor, otherwise you'll end up breaking it. Any excess power will add extra heat to the motor, too much and you'll melt the insides. Okay, how do we do this? First, remember the specification sheet I mentioned when I talked about motor selection? Whatever motor you choose, you will need its specification sheet here too. Also, remember the power cost numbers that I pointed out last time? You will need them. To review, the power cost numbers tell you how much electricity the motor needs to run. This is in voltage and, if the spec sheet has it, current. Take note of these numbers because this is what we will be matching our power sources to when we pick one. For this motor, we will need 24 volts, running at around 14.8 milliamps. So, what can we use to fulfill these numbers? Since the motors we will be primarily dealing with are DC motors, we can use batteries for a DC power supply. If you want to use batteries, you'll have two options. You can buy the respective battery based on the voltage or use several smaller batteries to try to match the voltage. Let's say we want to buy a respective battery based on a voltage. To do this, take the voltage from your specification sheet and search for a battery that matches. Easy. Well, not quite. Batteries have a secondary characteristic, amp hours. Basically, how many amps this battery will use in 1 hour, or how long this battery will last. When you pick a battery, you have to make sure that the voltage matches and that the battery will last for your needs. For example, for our motor, we need 24 volts to run it, so our battery needs to be 24 volt. But if I want it to last for 2 hours running all the time, then the battery also needs to be at least a 29.2 milliamp hour one. Let's say that you want to use several smaller batteries instead. To match up a battery's voltage, you connect the batteries in series. To match up a battery's amp hours, you connect them in parallel. See this infographic. But what about more than one motor? Then add up your current costs and pick a battery that can fulfill the new number. For the power supply, it's a bit simpler. Instead of worrying about amp hours, all you have to do is to make sure that the power supply can match the needed voltage and current. You also don't have to worry about multiple motors here since power supplies can easily power them too. The only con is that power supplies typically aren't portable. For our motor, the power supply needs to be rated at least 24 volts running at 14.6 milliamps. But a simple Google search shows that these numbers are a cakewalk for many power supplies. There's actually a lot more information in this process that I won't be able to cover here because of time, but do expect it in future videos. In my next video, I will talk about how to properly wire up and control your motor. Don't forget to like and subscribe. Thanks.